today we're looking at 8.4, which is talking about the sums of infinite geometric series. They start with talking about a partial sum. So if I want to add, for example, the first 10 terms or the first 20 terms, example 1 started with the first 10 terms of a series that looked like 1/2 plus 1/4 plus 1/8 plus ... In your book, they summed them manually. So the first term was 1/2. The sum of the first and the second was 1/2 plus 1/4, or 3/4, 0.75. And they did that for the first 5, and they graphed them. And notice how when they graphed, they approached 1. So it has a limiting value. And down below, where it's talking about the sums of infinite series, they showed you how they derived that term and found out that S of n was 1. I didn't write that down to you. Yes, I did. S of n, so the sum of that partial sum of the first 10 terms, in this case 10, was the first term plus 1 minus the common ratio raised to however many terms you're finding over 1 minus r. You do not have to do that by hand, and let me show you on your calculator. I think we've done this before, but I want to make sure you saw it again. So to do this with your calculator, I'm going to stat. Once you push that, you're going to be on edit and highlight L sub 1. So that first column, list 1, you want to be highlighted. Once that's highlighted, you're going to, while it's highlighted, push second stat and take your arrow key, your little arrow cursor key over to ops, and you're choosing 5 for sequence. When you've gotten that far, there'll be a little menu that pops up asking you for the expression. And if we're doing this series, I'm looking for, how would I write that? It's 0.5, because that's the first term, times r to the nth, r in this case, n minus 1. So I'm looking, my ratio was 1/2. So 0.5, that was the first term, times the ratio, 0.5, raised to the, in this case, x minus 1 power. The variable, choose x, starting at 1, ending at 10, because we're doing the first 10 terms. Our step is 1, because we're going to find 1, 2, 3, 4. Paste, so I'm entered. I get to paste, I put enter, and at that point, my list 1 would be filled with, should be 1/2, whatever I got. I should go back and look at that, I guess. Which should be what you've seen there. And then I'm going to highlight list 2. So I'm in stat, I've edited it, I've looked to see, whoops, I don't want to do that. Highlight list 2, and while that list is highlighted, you do second stat, and this time choose ops 6 for cumulative sum. And at that point, it'll be asking you, it'll say that, and you're looking, you want to put which list to look for. So you're doing second and the number 1. And if you look in blue, that says L sub 1. And so I'm pushing enter after I've entered that, and out should come the sums. See if I can get back to where I was. And out should come the sums. The first one was 0.5, the second one 0.75, all the way down to that 10th term, which was 0.9999. Approaching 1, which we saw when we graphed it. So just to review, let's stat, edit, highlight that first list, and then second stat over to ops 5 for sequence. Fill in the menu with your first term. This looks like the general term that would be in the summation, like a sub 1 times r to the whatever it was, in this case n minus 1. We're using x for our variable instead of n. So I'm down for the variable, choose x, start as 1, end at 10, step was 1, you pasted it, and your list was filled when you pressed enter. Once that was filled, you took your cursor and highlighted L2, which was the next list over, and I'm choosing, while that's highlighted, second stat, then ops, and this time you're choosing 6 for cumulative sum, and once you've done that, then you need to tell what list to use, and you do that by doing second and the number 1, because there was list of 1. And notice in that same row, list of 2, list of 3, with your keys. So that was leading to the core concept, which was saying that you can find, even though the series is infinite, you can sometimes find a finite sum. And that sometimes is if the absolute value of the common ratio is less than 1. It will approach a limit, and we say that limit is the value of the sum. So look at example 2. This is on page 437 in your textbook, and they gave you 3 things for which you were finding the sum. The first one, I goes from 1 to infinity. First term was 3. Common ratio was 0.7. I'm plugging into that formula. So the sum, this is less than 1, so we know it has a sum. The first term was 3. I'm doing 1 minus 0.7, so 3 over 0.3 to get 10 for my answer. If I'm looking at B, they gave me the series, 1, 3, 9, 27. So our first job was to figure out the first term, so that was easy to see. It was going to be 1. And the common ratio is 1 times 3, and then 3 squared. So if our common ratio was bigger than 1, which this one was 3, we know that no sum exists. And for the last one in that example, they gave us another series, 1 minus 3/4 plus 9/16. So the first order of business is to find what the first term is and what's the common ratio. So the first term, easy to see, that's 1. Remember your common ratio. If they told you it's a geometric series, I'm just dividing the succeeding term by the previous term. So I got negative 3/4 divided by 1, which is just negative 3/4. And then I'm plugging those values into that formula. So 1 minus negative 3/4 is 1 plus 3/4. 1 divided by 7/4 equals 4/7 when you simplify. So far, so good. Hopefully it's very straightforward. I'm looking at monitoring progress down at the bottom of page 437. You can either pause here or just work it with me. For that first one, where they're asking you to plot by hand, you can do that with your calculator the way that we did it, or you can just sum them up. I think there were only 5 of them. So if I'm looking at that, the first one was 2/5, which is 0.4, and the second one I'm adding 2/5 in the next term and getting 0.56, and the fourth term was 0.62, that's an approximation, and the fifth one was 0.64, and so if I did these far enough, it looks like I would be approaching 0.67, and you could do it on the calculator, or you can do it laboriously by hand. Either way, that was number 1. And then monitoring progress number 2 gave you a series, and so I've got that summation, n equals 1 to infinity, and this time it was negative 1/2 to the n minus 1. So first term is going to be 1 because 1 times that. So a sub 1 is 1, and my common ratio is negative 1/2, less than 1, so I'm going to plug that into that formula. And so S is the first term, which is 1, over 1 minus that 1/2, so 1 plus 1/2, 1 over, excuse me, 3/2, or 2/3 for your final answer. Looking at number 3, they gave you the summation as n equals 1 to infinity of 3 times 5/4 to the n minus 1. I don't have to go any further. 5/4 is greater than 1. This one has no sum existing. No sum exists for that one. It goes on infinitely big. And if I'm looking at number 4, 3 plus 3/4 plus 3/16. My first term is 3. And when I divide 3/4 by 3, I know my common ratio is going to be 1/4. And therefore, when I'm setting this up, 1/4 is less than 1. So I definitely have a sum. And that sum is the first term, so 3, divided by 1 minus 1/4. So 3 divided by 3/4, or 4 for my final answer. So far, so good. Then turn page and look at example number 3, where you got that pendulum they give it an initial swing and it goes 18 inches. And then they're saying that after that, it only does 80% of what was there. So they set it up 18 inches plus 80% of that 18 inches plus 80% of that. So the sum would look like that. And they're showing you then that the first term was 18, the second term is 0.8 because that's how far it went from term to term. And when they worked it out, they got 90, and that seems straightforward to me. So look at your book. And then example 4, I wanted to look at because you did writing repeating decimals as fractions. You did this before, probably in pre-algebra or maybe algebra 1, I can't remember whether we did that there, but for example, I've got 0.24, 24, 24, forever, and the job was to turn that into a repeating decimal. And the way we did that in pre-algebra was to look at how many decimals repeated, so in this case 2, so 10 to the 10 squared, so I have 100, x equals 24 point, and that repeating part just repeats. Well, if this is x, was our decimal in the first place, so x was 0.24, 24, etc. All those repeating parts canceled out, and so when you subtracted, you had 99x equals 24, and then you simplified, so x was 24/99, and if you looked at that, 3 goes into that, so 8 33rds. And that was the way we did it there, not too bad, easy to do. You can also do it as a geometric series, and that was what your book was showing you. So if I take that same number, 0.24, 0.24, 0.24, the first term is 0.24, and because we were multiplying that by 10 squared each time, my ratio is 0.01, and then I'm going to use that formula. S equals the first term divided by 1 minus my common ratio. And so I have 0.24 divided by 1 minus 0.01 is 0.99, and that's 24/99, and that happens to be 8/33, just like we got in the first place. So another way to do, another way to convert repeating decimals to fractions. Look at monitoring progress down at the bottom of that page. So number 5, suppose that pendulum only went 10 inches instead of 18. So now we've got 10 plus 10 times 0.8 plus 10 times 0.8 squared, just like we had before. First term is 10, and my common ratio is still 0.8 because it only went 80%. And so when we find the sum, it's 10 divided by 1 minus 0.8, or 10 divided by 0.2, which when you work that out was 50 inches. So that was number 5. Number 6 gave you a repeating decimal of 0.555. If I'm doing it as a geometric series, my first term is 0.5. My common ratio, there's only one digit that repeats, is 0.1. And so I have a sum of 0.5 divided by 1 minus 0.1, which is 0.5 divided by 0.9, which is 5/9. And if I look at number 7, they gave me a 2-digit repeating, 72, 72, ... So my first term is going to be 0.72. The common ratio is going to be 0.01 because 2 digits repeated. And so my sum is 0.72 divided by 1 minus 0.01, or 0.72 over 0.99, which is 72/99, or I could just reduce all at once and get 8/11, because 9 goes into both of those. So that was 6. There's another one, number 8. Which looks like 0.1313 ... So by this time we ought to be pros. The first term is 0.13 because those are the repeating digits. The common ratio is 0.01 because it repeats twice, so that's 10 squared, 100. And so S is 0.13 divided by 1 minus 0.01, which is 0.13 divided by 0.99, which is 13/99. Homework for this lesson is worksheets that are found under the topics tab and the answers to assignments, 8.4 worksheets 1 and 2. And that wraps us up, and I'll see you next time.